Welcome you all. Today's topic is Newton's forward interpolation method. This method is used to interpolate the values of f of x near the initial value of x. So we consider a set of x values along with corresponding f of x values. Suppose the x values are x0, x1, x2, etc., xn, and corresponding f of x values are y0, y1, y2, etc., yn. Here all the x values must be equidistant. That means x1 minus x0 must be same as x2 minus x1, and that should be same as x3 minus x2. Then f of x can be evaluated at any x which is nearer to x0, and using the formula f of x equal to y0 plus p into delta y0 plus p into p minus 1 by 2 factorial into delta square y0 plus p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y0 plus etc. plus p into p minus 1 into p minus 2 into etc. p minus n plus 1 divided by n factorial into delta raised to n y0. Here x is x0 plus ph. From this formula we have to evaluate p, and this h is step size, that is h is x1 minus x0 or x2 minus x1 or xn minus xn minus 1. All these will be same, and h is known as step size. Here delta y0 is y1 minus y0, and delta square y0 is delta y1 minus delta y0. Similarly, delta cube y0 is delta square y1 minus delta square y0. And these are known as first order, second order, third order differences respectively. All these values can be determined from forward difference table. Now we have a problem. The population of a town is as follows. Year 1941, 1951, 1961, 1971, 1981, 1991. And population in lakhs is also given. In 1941 it is 20 lakhs, then 24, 29, 36, 46, 51. Estimate population in the year 1946. Now we can see that this 1946 is nearer to initial x value 1941. So we can use Newton's forward interpolation formula to find out y value at 1946, or the population in the year 1946. So here x equal to 1946, h equal to 10. H is difference between any two consecutive x values, that is 1951 minus 1941. So we have h equal to 10. x0 is 1941, that is initial x value. Then we have x equal to x0 plus ph. From here we find out p by substituting x equal to 1946, x0 equal to 1941 and h equal to 10. We can get p equal to 0.5. Now in order to find out delta y0, delta square y0, delta cube y0, etc., we have to form forward difference table. This is forward difference table, in which first column contains X values 1941, 1951, 1961, 1971, 1981, 1991. Then second column contains Y values, that is 20, 24, 29, 36, 46, 51. Next column is first order differences, that is delta Y. So for getting delta Y, we have to subtract 24 minus 20, which is equal to 4. And the first order difference, first value is denoted as delta Y naught. The next one, 29 minus 24, which is equal to 5. This is delta Y1. Then 36 minus 29, which is 7, which is delta Y2. 46 minus 36, that is 10. Similarly, 51 minus 46, which is 5. Then second order differences. In second order differences, we have delta square Y naught, which is given by 5 minus 4, that is equal to 1. Then 7 minus 5, which is equal to 2, which is delta square Y1. Then 10 minus 7 equal to 3, 5 minus 10 equal to minus 5. Then delta cube Y, third order differences. So we have 2 minus 1, that is 1, which is equal to delta cube Y naught. Then 3 minus 2, again 1, minus 5 minus 3 minus 8. Then delta raised to 4y, that is fourth order differences. For getting this, we have 1 minus 1, which is equal to 0, denoted by delta raised to 4y naught. Then minus 8 minus 1, which is minus 9, which is delta raised to 4y1. Then we have fifth order differences, minus 9 minus 0. That is again minus 9, denoted by delta raised to 5y naught. So we have y naught 20, delta y naught 4, delta square y naught 1, delta cube y naught 1, delta raised to 4 y naught 0, delta raised to 5 y naught minus 9. So if we have 6 data, here, then you can find out up to fifth order differences, that is delta raised to 5 naught exists. Now we can substitute all these values in Newton's forward interpolation formula. The formula is y of x equal to y naught plus p into delta y naught plus p into p minus 1 by 2 factorial into delta square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial into delta cube y naught plus p into p minus 1 into p minus 2 into p minus 3 divided by 4 factorial into delta raised to 4 y naught plus p into p minus 1 into p minus 2 into p minus 3 into p minus 4 by 5 factorial into delta raised to 5 y naught. We have terms up to delta raised to 5 y naught. Then we substituting all the values, that is we substitute y naught equal to 20, p equal to 0.5, delta y naught equal to 4, similarly delta square y naught equal to 1, delta cube y naught equal to 1, delta raised to 4 y naught equal to 0, and delta raised to 5 y naught equal to minus 9. Now on simplification we can get the answer as 21.6914 lakh. That is, the population in the year 1946 is 21.6914 lakh. And we know this answer must be in between 20 and 24 because 1946 lies between 1941 and 1951. So obviously the population in 1946 will be in between 20 lakhs and 24 lakhs, and the exact answer and exact population in the year 1946 is 21.6914 lakhs. Now one homework, use Newton's forward interpolation formula to show that y at 23 equal to 39.913 from the following data. X values are 20, 25, 30, 35, 40, 45 and corresponding y values are 34.3, 32.1, 29.3, 25.6, 22.7 and 21.9. Now thank you.